Hi everyone, my name is Mimi Ismail. I'm a PhD student here at the Center for Hydrates Research. Today I'm going to share with you the equipment that I'm working with, which is called High Pressure Micromechanical Force, or for short is MMF. So this is how MMF looks like. We have the microscope here at the top and the pressure cell located here. To start with the experiment, first we have an aluminum cell where we place in the mineral oil with a mixture of crude oil or Antiglomerin. Then we have stirrer bar to have better mixing of the solution. Next, we will form two hydrate particles at the tip of a glass fiber. This is how the glass fiber looks like. We will form the hydrate particles at the tip of the glass fiber, and the size of the hydrate is about 400 micrometers in diameter. Next, we will close the pressure cell, and it's now ready to pressurize up to 500 psig. And to observe the hydrate conversion inside the cell, we have microscope where we could monitor the video from the computer. After letting the hydrate to convert for about 2 hours, we then ready for the cohesive force measurements. The force values is calculated by using Hooke's law, where we use the spring constant K and multiply it with the displacement of the two hydrate particles. Now I'm going to show some results that we have for the cohesive force values between two hydrate particles in an oil-dominated system. The graph here showing the cohesive force at the y-axis, and at the x-axis we have the contact or the shut-in time. For 10 seconds of contact time, as we can see from the video on the left here, the values for the cohesive force is about 23 milliNewton per meter. And when we increase the contact time to 24 hours, as we can see from the video on the right hand side here, the two hydrate particles can no longer be separable, resulting in a higher force than the one at 10 seconds contact time. With that, we could have a linear relationship between the cohesive force and as well as the contact time when we plot it in the graph here. We also have performed measurements by injecting commercial Antiglomerin in the system. From the graph here, the black trend shows the results without the addition of AA into the system. And when we add in AA into the system, we can see that the cohesive force reduced significantly. Other than the cohesive force, we also observe such an interesting morphology changes to the hydrate particles when we injecting the AA into the system. As you can see from the video here, the two hydrate particles can no longer maintain its spherical shape and it starts to crumble. This result is a reflection of what is happening in the oil and gas pipeline when AA is being injected. We also have performed measurements by adding crude oil into the system. This measurement was performed for the evaluation of the hydrate non-plug-in properties of the crude oil. That's all I have for the MMF. Thank you.